Somewhere in the freezing dark of the Arctic Ocean, a shark is swimming right now that was alive before the United States was a country. Before electricity, before cars, before your great-great-great-grandparents were even born. This is the Greenland shark, and scientists believe it can live past 400 years old. In this video, we're diving into a creature with a glowing parasite stuck to its eyes, flesh so toxic it can get you drunk, and a slow, silent life hidden almost a mile under the ice. If you want more deep-sea mysteries like this, hit subscribe. It helps more than you know. Get comfortable. This one is going to mess with your sense of time. Picture this. Somewhere off the coast of Greenland, in water so cold it would kill you in minutes, a shark is gliding through the dark right now. It has been alive since before George Washington was president, before the Declaration of Independence was signed, before the first American flag existed. That shark is still out there today, still swimming, still alive. This is not a myth or a legend passed down by old sailors. This is a real animal, confirmed by real scientists, using real science. Its name is the Greenland shark, and it might be the oldest living animal with a backbone on the entire planet. To put that in perspective, imagine a person who watched the invention of the light bulb, lived through 2 world wars, and is still walking around today, ordering coffee like nothing happened. That is basically what this shark has done, just underwater, in freezing silence, for centuries. For most of history, nobody knew this. Fishermen caught these sharks by accident for years and had no idea they were pulling up animals older than their own family bloodlines. Nobody suspected that this slow, strange fish drifting past their boats had already been alive when their great-great-great-grandparents were children. The Greenland shark looks nothing like a great white or a hammerhead. It moves slowly. It has small eyes, a heavy blunt snout, and skin like sandpaper. On the surface, it does not look powerful. It does not look majestic. It looks tired, almost ancient, like something that has seen too much. And it turns out, that is exactly what it is. Scientists did not stumble onto this discovery by accident. They spent years trying to answer one simple question. How old can this animal actually get? The answer they found broke every expectation science had about how long a vertebrate, an animal with a backbone, can survive. Fish, mammals, birds, reptiles, none of them were expected to come close to this number. But the Greenland shark did. And once researchers confirmed it, they realized they were not just looking at an old fish. They were looking at a living timeline. A creature that has personally existed through more human history than almost anything else alive on Earth today. Every war you have read about in a textbook, every president, every invention, from the printing press to the smartphone in your pocket. This shark was likely already alive for some of it, silently swimming in the dark, completely unaware and unaffected by any of it. While human civilizations rose and collapsed, while entire empires came and went, this shark just kept doing one thing, surviving, slowly, quietly, in water so cold and so deep that almost nothing else can survive down there with it. So how did scientists figure out something this wild? How do you even guess the age of a fish that could be 4 centuries old? It turns out, the answer almost did not happen at all, because sharks are missing the one biological tool scientists normally rely on to measure age. And that missing piece is exactly where our story really begins. In the early 2000s, marine scientists were studying Greenland sharks for a completely different reason. They were not hunting for a record. They were not trying to find the oldest animal on Earth. They just wanted to understand these strange, slow-moving fish that live in the freezing Arctic and North Atlantic. But the deeper they looked, the more confused they became. Something did not add up. Greenland sharks grow incredibly slowly, less than 1 centimeter a year. That is slower than your fingernail grows. Scientists already knew some individual sharks were massive, stretching over 16 feet long, roughly the length of a small school bus. If you do the simple math, growing 1 centimeter a year. To reach that size, the shark would have to be far older than any shark had ever been recorded. At first, researchers thought there had to be a mistake. Maybe their growth rate calculations were off. Maybe the sharks grew faster when they were young and slowed down later, the way some animals do. It would make more sense. It would fit what they already believed about ocean life. But every test they ran kept leading back to the same unsettling possibility. These sharks might genuinely be hundreds of years old. That is the kind of number that makes a scientist stop and question everything they thought they knew. Because in the world of vertebrates, animals with a backbone, nothing gets close to that. Some tortoises live past 100. Some whales live past 100. But 400 years is a different category entirely. That number does not belong on the same chart as other animals. It stands alone. So the research team knew they could not just guess. They needed actual proof. They needed a method that could nail down an exact age, not an estimate based on size and growth speed. And that search for proof was about to run into a brutal problem. The tool scientists use on almost every other fish on Earth to measure age simply does not exist on a Greenland shark. It is missing completely. No backup version. No workaround. Nothing to count. Nothing to measure. Nothing to slice open and read like the rings of a tree. For a while, it looked like the mystery might never be solved. How do you prove an animal is 400 years old if the one clue that normally cracks the case is not there at all? The team was stuck, staring at a fish that might be the oldest living vertebrate on the planet, with absolutely no direct way to prove it. That gap, that missing piece of biology, is exactly why answering this question took years of failed methods and creative thinking before anyone got close to the truth. And to understand why they were so stuck, you first have to understand what every other fish has that this one does not. If you want to know how old a tree is, you cut it down and count the rings. Every single ring is 1 year of life, growing outward, layer by layer. Marine biologists have a similar trick for most fish. Inside a fish's inner ear is a tiny, hard structure called an otolith. Think of it like a stone that grows in rings, just like a tree, adding a new layer every year. Cut it open, count the rings, and you know the fish's age. Simple, reliable, and used all over the world on thousands of fish species. Here is the problem. Sharks do not have otoliths. Not weak ones, not small ones, none at all. Sharks are built differently from most fish. Their entire skeleton is not made of bone, it is made of cartilage, the same flexible material that shapes your ears and the tip of your nose. No bone means no otolith, and no otolith means no built-in growth rings to count. So the number one tool marine biologists reach for first was completely useless on a Greenland shark. This left scientists with a real problem. They had a fish that might be the oldest vertebrate on the planet, and no direct way to prove it. It is like trying to figure out someone's exact age with no birth certificate, no ID, and no photographs from any point in their life. You would have to get creative, and that is exactly what shark researchers were forced to do. They looked everywhere else on the shark's body for anything that might have grown in a slow, steady, measurable pattern. They checked the spine. Some shark species have layered growth bands in their vertebrae, similar to tree rings, but Greenland sharks did not give clean or reliable results this way. They looked at body size and growth rate, but that only gave rough estimates, not exact numbers. And as we already saw, those estimates were pointing toward hundreds of years, which nobody could fully trust yet without harder evidence. Every path researchers tried either failed completely or gave them a foggy, uncertain answer. Not exact, not scientific enough to publish, not enough to claim a new record for the oldest living vertebrate on Earth. For a while, it seemed like the true age of this shark might stay a mystery forever, locked away with no way to unlock it. Then, one research team decided to stop looking at the outside of the shark completely. Instead, they turned their attention to something deep inside its eyes, a part of the body that barely anyone had considered before, a part of the body that, strangely enough, stops changing almost entirely after birth. That single decision was about to change everything scientists thought they knew about this animal. And it all started with a part of the eye most people do not even know exists. Deep inside every shark's eye is a small, clear structure called the lens. Its job is simple. It helps focus light so the shark can see. But scientists discovered something strange about this tiny piece of the eye. It is not just useful for seeing, it might be the key to unlocking the shark's entire life story. Here is why. When a shark is still developing before birth, its eye lens starts forming layer by layer, kind of like an onion. But once the shark is born, something interesting happens. The center of that lens, the very core, stops changing completely. It stays exactly the same for the rest of the shark's life, frozen in time from the moment it was born. That means the core of the lens is basically a time capsule. It holds a chemical signature from the exact year the shark came into the world, and that signature never gets erased, replaced, or updated as the shark grows older. If scientists could read that chemical signature, they would essentially be reading the shark's actual birth year. But there was still a problem. Reading it required an extremely precise scientific method, one that could detect tiny chemical traces left behind from a specific moment in history. Luckily, scientists already had a tool built exactly for that. It is a method most people only associate with dinosaur bones and ancient artifacts. Carbon dating. You have probably heard this term in a history class or a documentary about ancient ruins. It is normally used to figure out the age of things like fossils, artifacts, or human remains that are thousands of years old. Nobody had ever seriously tried using it on a living shark's eye before. It sounds strange, testing part of a living animal using a method built for ancient fossils. But that is exactly what this research team decided to try. If it worked, it could finally give them something they never had before, an actual number, a real, testable age, not just a guess based on size or growth speed. This was the turning point. If the eye lens held a chemical fingerprint from the year the shark was born, and carbon dating could read that fingerprint accurately, then scientists would finally have hard proof of just how old these sharks really are. No more estimates, no more foggy growth rate math. Just cold, hard data pulled from inside the shark's own eye. But carbon dating a shark's eye was not going to be simple. It required incredibly delicate lab work, careful sample collection, and comparing the results against something very unusual, something connected to nuclear bomb testing from the 1950s, something that, strangely enough, is now key to timestamping animals all over the world. And that connection is where the story gets even stranger. Here is where the story takes a strange turn, one that connects a deep sea shark to nuclear bomb testing from the 1950s. During that decade, countries around the world tested nuclear weapons above ground. Those explosions released a burst of radioactive carbon into the atmosphere, way more than existed naturally before that point. This spike in radioactive carbon spread across the entire planet. It sank into the ocean. It got absorbed by plants and animals everywhere, including tiny sea creatures at the very bottom of the food chain. Scientists later realized this nuclear spike left something incredibly useful behind, a marker in time, a detectable signature baked into every living thing that existed after the 1950s. Think of it like an invisible timestamp, quietly written into nature. If scientists could find that same radioactive marker inside a Greenland shark's eye lens, in the layer formed the year it was born, they could compare it to that global spike and calculate the shark's exact birth year. Remember, the center of a shark's eye lens does not change after birth. It stays locked in time. So, if that spike shows up in the layer at the very center, the shark was born around the 1950s. If the spike is completely missing, that means the shark's lens core, and therefore the shark itself, formed before nuclear testing ever began. And that is exactly what researchers found. When scientists tested the eye lenses of several Greenland sharks, some individuals showed no radioactive spike anywhere in their eyes. None, not even close. Which meant These sharks were already alive, already fully formed, years before the first nuclear bomb was ever tested. Some of these sharks were swimming in the Arctic long before World War II, long before airplanes filled the sky, long before most of the technology we consider normal today even existed. Using this method, combined with growth rate calculations, researchers estimated one particular female shark was approximately 390 years old, though the range of possible age stretched even further, from 272 years old up toward 500. Even the most cautious, most conservative version of that number was still shocking. It shattered every previous record for vertebrate lifespan by centuries, not by decades. This was not a rough guess anymore. This was measurable, testable, scientific proof, and it fundamentally changed how scientists think about aging, biology, and what is even possible for a living creature. But one number matters more than any other in this story, because it represents the oldest confirmed estimate scientists have found so far. And that number is so extreme, it forces you to rethink everything you assumed was possible for a living creature on this planet. Let that number sink in for a second. 390 years old, possibly older, possibly reaching close to 500. To put that in perspective, if that shark was born 500 years ago, it would have started its life around the time Christopher Columbus was still alive. That is not a typo. That is not an exaggeration for dramatic effect. That is what the science actually suggests is possible for this species. Before this discovery, the oldest known vertebrate on Earth was the bowhead whale, which can live past 200 years. That was already considered incredible. 200 years already sounded almost unbelievable for something with a backbone, a heart, and blood pumping through its body. But the Greenland shark did not just break that record, it obliterated it. It nearly doubled it. This pushed the Greenland shark into a completely different category of animal, one that barely makes sense next to anything else alive today. Most animals with a backbone live for a few years. Some live for a few decades. A rare few make it past 100. But almost nothing, absolutely nothing, was expected to blow past 400 years. When this research was published, it did not just impress scientists. It forced a lot of people in the field to rethink their basic assumptions about aging itself. If a Greenland shark can survive this long, what does that mean for how we understand aging as a biological process? What is different about this animal on a cellular level? Why does its body not seem to break down the way every other creature's does over time? These are not simple questions with easy answers, and honestly, scientists still do not have most of them figured out. Here is something that makes this even more mind-bending. If that 390-year estimate is accurate, this shark would have already been alive and swimming through the ocean before the United States was ever founded as a country. It would have been alive during the Salem witch trials. It would have been swimming in the exact same ocean while entire empires rose to power and eventually collapsed centuries later. It was there through almost the entire span of recorded American history, and possibly long before that too, silently drifting through freezing dark water the entire time, completely unaware and untouched by any of it. This raises an obvious next question, one that naturally follows this discovery. If this shark has been alive for centuries, what has it actually been doing all that time? How does an animal survive for 400 years without breaking down, without giving out, without simply running out of time the way everything else eventually does? The answer connects to something surprising about temperature, metabolism, and exactly how slow this shark's entire life truly moves. And that is where our story goes next. Try this thought experiment for a second. Think about your great-great-great-grandparent, someone from 5 generations back in your family. You probably do not even know their name. You have likely never seen a photo of them. They lived and died long before you were even a thought, in a completely different century, dealing with a version of the world that would feel foreign and strange to you today. Now here is the wild part. A Greenland shark alive today could have already been swimming in the ocean before that ancestor of yours was even born. While your family tree was forming generation after generation, marriages, births, migrations, wars survived. Entire family lines starting and continuing. This shark was doing one single thing the entire time, existing, slowly, quietly, alone in the cold, dark water, completely disconnected from everything happening on land. It did not know about your family. It did not know about any human history unfolding above the surface. It just kept swimming, kept growing at its impossibly slow pace, and kept surviving, decade after decade, generation after generation, while entire human bloodlines rose and changed around it without it ever noticing. This is genuinely hard for a human brain to process, because we do not experience time this way. Our lives move in a completely different rhythm. We grow up fast. We change constantly year to year. We measure our lives in decades, not centuries. 400 years is not just a long time to us. It is almost incomprehensible, something closer to a concept from a history book than an actual living timeline. But for the Greenland shark, that timescale is not unusual at all. It is simply normal life. This raises a genuinely fascinating question that scientists are still trying to fully answer. What does it actually feel like, biologically speaking, to live on a timescale like that? Does the shark's body experience time differently than ours does on some cellular level? Does its brain, its cells, its entire internal biology operate on a completely different clock than every other animal on Earth? We know humans and most other animals experience aging in a fairly predictable pattern. Cells divide, tissues wear down. Systems slowly break down over time until the body simply cannot keep going anymore. But the Greenland shark seems to laugh in the face of that entire process, stretching it out over a timeline that makes zero sense compared to almost every other living creature we know of. So, what is actually going on inside this animal that allows it to survive this long? Scientists believe part of the answer has to do with something surprisingly simple, something related to the freezing water this shark calls home, and exactly how that extreme cold might be quietly rewriting the rules of biological aging itself. Greenland sharks live in some of the coldest water on Earth, often just above freezing, sometimes hovering right around 34 degrees Fahrenheit. That is barely warmer than ice. To put that in perspective, that is colder than your refrigerator at home. Most animals could not survive in conditions like that for long, but scientists believe this extreme cold might not just be something the Greenland shark tolerates. It might actually be the secret behind its incredibly long life. Here is the basic idea. Cold temperatures slow down chemical reactions. This is true in chemistry class, and it is true inside a living body too. In freezing water, an animal's metabolism, which is basically the speed at which its body burns energy and carries out all its internal processes, slows way down. Think of it like a candle. A candle burning fast and bright melts down quickly and does not last very long, but a candle burning low and slow can last for hours longer, sometimes far longer than you would expect. Scientists believe the Greenland shark's body works in a similar way. Because it lives in such cold water, its metabolism runs at an extremely slow pace. Its heart beats slowly. Its cells divide slowly. Every single biological process inside its body happens at a fraction of the speed you would see in a warm water animal, like a great white shark or a tuna. This slow pace might be exactly why the Greenland shark ages so slowly compared to almost every other animal on the planet. If your body is running at a fraction of normal speed, biologically speaking, your entire life might stretch out to match that pace. This idea connects to something scientists have observed in other cold-blooded animals too. In general, across many species, colder environments tend to correlate with slower aging and longer lifespans. It is not a guaranteed rule that applies to everything, but it shows up often enough that scientists take it seriously as a real biological pattern. The Greenland shark might simply be the most extreme example of this pattern that we have found so far anywhere on the planet. This is still considered a theory, not a fully proven fact. Scientists do not have 100% certainty that cold water alone fully explains the shark's extreme lifespan. There could be other genetic or biological factors involved that researchers have not fully identified or understood yet. But the connection between freezing water and slowed aging is strong enough that most researchers studying this animal take it very seriously as a major piece of the puzzle. If this theory holds up, it means the Arctic Ocean itself might be acting like a natural refrigerator for life, slowing down time itself for anything that can survive inside it long enough. Which raises an entirely new question. What else about this frozen, hostile environment might be helping this shark live for centuries, quietly working in its favor the whole time? Imagine an entire ocean acting like a giant refrigerator, quietly preserving life inside it for centuries at a time. That is basically what the Arctic deep might be doing for the Greenland shark. This is not just about cold water alone. It is about an entire environment that seems almost perfectly designed, at least by coincidence, to slow everything down to an extreme degree. Greenland sharks are typically found in extremely deep water, sometimes plunging beyond 7,000 feet down, an area so deep that sunlight cannot reach it at all. This part of the ocean is called the deep sea, and it is a completely different world from the sunny surface waters you picture when you think of the ocean. Down there, it is permanently dark. It is silent almost all the time. And crucially, the temperature stays freezing cold and incredibly stable all year round, barely changing at all no matter the season above the surface. This stability might matter just as much as the cold itself. Think about it this way. Extreme swings in temperature can stress a living body, forcing it to constantly adapt and burn extra energy just to keep up with the change. But a stable, unchanging environment, one that never gets warmer or colder no matter what, removes that stress completely. It might allow an animal's body to settle into an extremely efficient, low-energy rhythm and simply stay there, undisturbed, for decades or even centuries at a time. Add to that the immense pressure of the deep ocean, which is significantly higher than anything at the surface, and you get an environment that is almost alien compared to anywhere humans can easily survive without serious equipment. And yet, for a Greenland shark, this crushing, freezing, permanently dark world is simply home. It is not a hostile place it merely tolerates. It might be the exact reason this animal can live as long as it does in the first place. Some scientists believe this deep, stable, cold environment essentially acts like a natural form of suspended animation, though not in the dramatic science fiction sense you might be picturing. Nothing is frozen solid or paused completely. It is more like everything inside the shark's body is running in extreme slow motion all the time, every single day, for hundreds of years, straight without pause. This raises a genuinely interesting question for scientists still studying this animal today. If the environment itself is a major part of why this shark lives so long, what does that mean for its actual biology on the inside? What is happening at the level of its heart, its cells, and its organs that allows this slow-motion lifestyle to actually work without the body simply breaking down? The answer takes us even deeper into the shark's body itself, starting with the one organ every animal depends on to survive, its heart, and exactly how slowly it might be beating this entire time. Every heartbeat in your body takes a small amount of energy. Multiply that by the thousands of beats your heart makes every single day, and you start to understand how much work your heart is constantly doing just to keep you alive. Now imagine a heart that beats far slower than that. So slow it almost seems impossible for an animal to stay alive at all. Some researchers estimate a Greenland shark's heart might beat as slowly as once every 10 seconds, though exact numbers are still being studied and confirmed. Compare that to a human heart, which beats around once per second when you are resting calmly. That means for every single heartbeat inside a Greenland shark's chest, your heart could have already beaten around 10 times. This dramatic difference connects to a pattern scientists have noticed across many different animal species. In general, animals with slower heart rates tend to live longer than animals with fast heart rates. A mouse, for example, has an extremely fast heartbeat, and it typically only lives for a year or two. An elephant has a much slower heartbeat compared to a mouse, and it can live for many decades. This is not a perfect rule that applies to absolutely everything in nature, but it shows up often enough across the animal kingdom that scientists consider it a meaningful biological pattern worth paying attention to. The basic idea is that a slower heart rate often means the entire body is running at a slower overall pace, which may reduce the amount of wear and stress placed on the body over time. Now take that same pattern and stretch it to its most extreme possible version. A heart beating once every 10 seconds, inside a body already built for an incredibly slow metabolism, living in freezing, stable water for its entire life. That combination might be a major part of the secret behind the Greenland shark's astonishing lifespan. It is like comparing a car engine running at a gentle, steady idle for hours on end, compared to one constantly redlining at maximum speed. The one running gently, steadily, and slowly is going to last dramatically longer before it finally wears out completely. This slow heartbeat is not happening in isolation either. It connects directly back to everything we have already covered: the freezing water, the incredibly slow metabolism, the deep, dark, stable environment this shark calls home its entire life. Every single piece fits together like an interconnected puzzle, all pointing toward the exact same outcome. An animal that experiences and processes time completely differently than almost anything else alive on this planet today. Which leads to a genuinely fascinating question scientists are still exploring. If this shark's entire body runs on a slower internal clock compared to ours, does that mean it also experiences and processes the actual passage of time differently than we do? Here is a strange idea to sit with for a second. What if time itself does not feel the same for every living creature? We tend to assume time moves at the same steady pace for every animal on the planet, but biologically speaking, that might not actually be true. Every living thing runs on its own internal biological clock, and that clock can move at wildly different speeds depending on the animal. A hummingbird's heart can beat over 1,000 times per minute. Its entire life moves in fast motion compared to ours, constantly buzzing with energy, burning through resources quickly, living an intense but relatively short life. A Greenland shark exists at the complete opposite extreme end of that same scale. Slow heartbeat, slow metabolism, slow growth. Every part of its biology moves at a fraction of the pace you would see in almost any other animal alive today. If a hummingbird experiences life in fast motion, the Greenland shark might be experiencing life in true slow motion, stretched out across centuries instead of years. This does not necessarily mean the shark consciously feels like time is moving slowly in the way a human might understand or imagine that experience. Scientists cannot climb inside a shark's brain and ask it directly how time feels from its perspective. But biologically speaking, every single system inside its body, its cells, its organs, its overall growth and development, all of it is operating on a completely different timeline compared to almost every other creature we know of. Consider this comparison for a moment. A dog's entire lifespan might last around 12 to 15 years. Within that relatively short window, a dog is born, grows up, plays, ages, and eventually dies. A Greenland shark could live through 25 to 30 full dog lifespans, stacked back to back, one after another, and still keep going strong afterward. That is an almost impossible number to fully wrap your head around. It means a single Greenland shark could theoretically exist through multiple entire human lifetimes as well, watching generation after generation of humans live, grow old, and eventually pass away, while it continues on, completely unaffected by any of it. This single idea completely reshapes how scientists think about aging as a biological process in general. If an animal's body can genuinely run this slowly and still function normally without breaking down, What does that reveal about the actual limits of biology itself? Is a fast lifespan truly required for survival? Or is it simply one possible strategy among several very different ones nature has developed over time? The Greenland shark suggests it might be the second option, and that idea alone is already reshaping how many scientists think about aging across the entire animal kingdom. To really understand just how extreme this slow-motion life truly is, it helps to translate shark years into terms our human brains can actually process and relate to. Let's put this into numbers your brain can actually hold on to. If a Greenland shark lives around 400 years, and the average human lives around 80 years, that means one single shark could outlive 5 full human lifetimes stacked back to back, one after another. Think about everything one person experiences across an entire 80-year human life. Childhood, school, a career, relationships, maybe children, maybe grandchildren, an entire lifetime of memories, decisions, and change. Now multiply that by 5. That is one Greenland shark's potential lifespan, all happening while it simply exists quietly in cold, dark water the entire time, likely not doing very much at all compared to a human's busy, event-filled life. Here's another way to picture it. If you compare a Greenland shark's growth rate to how humans age, and you tried to line up their timeline with typical human milestones, one estimate suggests Greenland sharks might not even reach full sexual maturity until they are around 150 years old. Stop and really think about that for a second. If a human had to wait proportionally that long before reaching adulthood on a similar scale, we would essentially need to survive multiple centuries before growing up at all. It is an almost impossible comparison to fully wrap your head around using a normal human timeline. This slow pace applies to seemingly everything about this animal, not just aging in general. Growth, reproduction, basic development. Every part of a Greenland shark's life moves at a pace that feels closer to geological time, like the slow shifting of continents or the gradual formation of mountains, rather than a normal biological lifespan we would recognize in almost any other creature we know of on Earth. Now here's a thought that might genuinely give you chills. Because Greenland sharks can live for centuries, some individuals alive in the ocean today were already fully grown adults before your great-grandparents were even born. They were likely already massive, fully mature sharks, quietly patrolling the freezing depths of the Arctic Ocean, decades and decades before you existed, before your parents existed, before almost anyone currently alive today existed. And they are most likely still out there right now, in this exact moment, continuing on as if absolutely nothing about the world above the surface has changed at all in that entire time. This raises an obvious and fascinating next question. If this shark grows so incredibly slowly, taking centuries just to reach full adult size, what does that slow growth process actually look like happening in real time? Why does growing just 1 single centimeter per year matter so much to its overall survival strategy? And what does that number actually reveal about how this animal's entire biology is built to last? 1 centimeter. That is roughly the width of your pinky finger. Now, imagine that tiny amount of growth is all a Greenland shark manages in an entire year. That is the average growth rate scientists have recorded for this species, and it is almost unbelievably slow compared to nearly every other shark species on the planet. Compare that to a great white shark, which can grow several inches taller every single year during its early life stages, especially while it is still young. A great white shark can reach a large, intimidating adult size within just a decade or 2 of being born. A Greenland shark, growing at barely 1 centimeter per year, would need centuries just to reach a similar overall length. On the surface, that might sound like a massive disadvantage in the animal kingdom. Slower growth usually means an animal stays smaller and more vulnerable to predators for a much longer stretch of time before finally reaching a safer adult size. But here's the surprising twist to this story. That incredibly slow growth rate might actually be a hidden superpower rather than a disadvantage at all. Growing quickly requires an enormous amount of energy. Cells have to divide rapidly, The body has to build new tissue constantly, over and over, again and again. All of that rapid cellular activity creates something scientists call oxidative stress, which is basically wear and tear happening at the cellular level, similar to how a machine running at maximum speed constantly generates extra heat and friction that gradually breaks it down over time. Animals that grow fast often experience more of this cellular wear and tear throughout their bodies, and many scientists believe that this kind of ongoing stress may contribute directly to faster aging over an animal's overall lifetime. Growing at an extremely slow pace might reduce that same cellular stress dramatically year after year, potentially allowing the Greenland shark's body to hold up and function properly for centuries instead of just a few short decades like most other species. It is like comparing two people running the exact same marathon. One person sprints as hard and as fast as they possibly can right from the very start, burning through their energy reserves almost immediately. The other person paces themselves deliberately, moving slowly and steadily, conserving their energy carefully for the entire distance. The person who paces themselves is far more likely to actually finish the race in good condition without completely breaking down partway through from exhaustion. The Greenland shark appears to be nature's ultimate example of pacing itself, stretched out dramatically across literal centuries instead of just a few hours or days like a human marathon runner. This raises a genuinely interesting question about survival strategy in general. In a fast-moving ocean environment full of quicker predators and faster-growing competition, how exactly does an animal that grows this slowly manage to survive long enough to reach adulthood in the first place? The surprising answer connects directly to the extreme, frozen world this shark calls home for its entire life. Think about the ocean for a second, the way most people usually picture it. Fast predators chasing down prey, sudden, explosive bursts of speed, dramatic, high-energy hunts playing out constantly beneath the waves. That is the ocean most nature documentaries choose to show us, because it looks exciting and dramatic on camera. But that fast-paced, high-energy version of ocean life is not the only story happening down there. In the deep, freezing waters where Greenland sharks live, a completely different set of rules seems to apply entirely. Down in that Arctic darkness, speed does not matter nearly as much as it does near the surface. There is very little light. There is very little competition from other fast-moving predators, since most other species cannot survive in water that cold and that deep in the first place. And critically, there is no need to constantly outrun anything else, because almost nothing else is built to survive down there at all. This creates a strange kind of opportunity for an animal like the Greenland shark. In a slow, cold, mostly empty world, being slow yourself is not actually a weakness at all. It might genuinely be an advantage. The Greenland shark does not need to sprint after fast-moving prey to survive and thrive. It does not need to constantly outcompete other quick predators for food in a crowded ecosystem. It simply needs to exist patiently, conserve its energy carefully, and wait for opportunities that come its way naturally over time. This slow, patient lifestyle likely connects directly to its almost unbelievable lifespan. If you do not have to constantly sprint, fight, or compete aggressively for survival every single day, your body does not experience nearly as much stress or physical wear over time. Less physical stress on the body may very well mean a much longer potential lifespan overall, stretched out across centuries instead of just a handful of decades. It is a little bit like comparing a race car engine to a diesel truck engine. The race car engine is built purely for intense, explosive bursts of speed, but it tends to wear out relatively quickly under all that repeated strain and pressure. The diesel truck engine runs slower and steadier overall, but it can often keep running reliably for an incredibly long time, sometimes decades longer than the race car ever could. The Greenland shark's entire body and lifestyle seems to be built more like that steady, reliable diesel engine, engineered by evolution over millions of years for extreme long-term endurance rather than short bursts of speed or explosive power. But here's a fair question worth asking at this point in the story. If this shark really does move this slowly through life, how does it actually manage to hunt and eat anything at all down there in that freezing darkness? The answer to that question gets even stranger, and it involves a bizarre, glowing parasite that many of these ancient sharks carry directly on their eyes. Here's something that sounds almost too strange to be true, but it is fully confirmed and documented by marine biologists. Many Greenland sharks swim around with a small, glowing parasite attached directly to their eyes, not near their eyes, not close to their eyes, directly on them, latched onto the surface of the eyeball itself. This parasite is a tiny copepod, a small crustacean related to shrimp, and it attaches itself firmly to the shark's cornea, which is the clear outer layer covering the eye. Over time, this parasite can severely damage the shark's vision, and in a significant number of cases, it can cause partial or even complete blindness in that eye entirely. Here's the part that sounds like something straight out of a science fiction movie. This tiny parasite glows. It produces its own natural light through a process called bioluminescence, similar to how a firefly produces its glow on a summer night. Picture this for a second. A 400-year-old shark drifting silently through the pitch-black Arctic depths with a small, glowing light stuck directly onto its eye, like some kind of alien attachment. It sounds like a scene ripped straight from a science fiction film, but it is completely real, and it happens far more often than most people would ever guess or expect. Scientists estimate that a significant percentage of Greenland sharks studied so far show clear signs of this parasite attached to at least one eye. In many of these documented cases, it has caused serious, measurable damage to the shark's overall vision over time. So here's an obvious and fair question. How does a mostly blind shark survive for centuries in the freezing darkness of the deep ocean without being able to see properly? It actually might not need clear eyesight at all to survive successfully down there. In water this deep and this dark, eyesight is not nearly as useful or necessary as you might initially assume it would be. There is barely any usable light this far down in the first place, so relying heavily on vision would not help most animals survive much anyway, whether they are predators or prey trying to avoid one. The Greenland shark appears to have evolved other ways entirely to sense the world around it that do not depend on sight at all. This raises a genuinely fascinating next question, worth exploring further. If this shark cannot rely on clear vision to guide it, then how exactly does it successfully find food down there in the pitch darkness? How does a mostly blind predator manage to hunt or scavenge or simply survive for centuries at a time in a world with almost no usable light whatsoever? The surprising answer might completely change the way you think about what it actually takes to survive and thrive in the deepest, darkest parts of our entire ocean. Losing your eyesight would be devastating for most predators. Vision helps animals track movement, spot prey from a distance, and react quickly to sudden danger nearby. So, how does a Greenland shark, one that is often partially or even completely blind because of that strange glowing parasite, manage to survive and even thrive for centuries in the deep ocean? The answer lies in a sensory system most humans do not even know exists. Sharks in general have a special ability called electroreception. Scattered across a shark's snout are tiny, jelly-filled pores, called the ampullae of Lorenzini. These specialized organs can detect the faint electrical signals that every living creature naturally gives off, including the tiny electrical pulses created every time a muscle contracts or a heart beats. Every single fish swimming nearby, every seal, every living creature moving through the water is constantly broadcasting a faint electrical signal. Whether it realizes it or not, a shark can sense this signal directly, almost like having a built-in radar system that does not rely on light or vision at all. For a Greenland shark living in a world without usable light, this ability becomes essential for survival rather than just a helpful bonus. It does not need clear eyesight to detect a fish swimming nearby in the darkness. It can sense the electrical field given off by that fish's own beating heart and moving muscles instead, tracking it directly through the water like an invisible signal. Combine that electrical sense with an extremely powerful sense of smell, which many shark species rely on heavily to locate food from surprisingly long distances away, and you get a predator that barely even needs eyesight at all to hunt successfully. Losing its vision to a parasite might be a serious inconvenience for this shark, but it is far from a fatal or life-ending problem for a creature already built with backup senses this powerful and reliable. This raises a genuinely interesting question about the parasite itself. If the parasite significantly damages the shark's vision this severely, why would the shark tolerate having it attached to its eye in the first place, instead of trying to remove it? Some scientists have proposed an interesting and slightly strange theory to help explain this. Because the parasite glows continuously in the darkness, it might actually help lure small, curious prey close enough to the shark's mouth to be caught and eaten, almost like a living fishing lure attached directly to its face. This idea remains a theory rather than a fully confirmed scientific fact at this point, but it is a fascinating possible explanation nonetheless. It would mean the very same parasite that blinds this ancient shark might also be quietly helping it eat simultaneously. This leads directly into another deeply strange fact about this animal, one that sounds almost too bizarre to actually be true. The flesh of the Greenland shark itself is toxic, and that single trait might be doing far more to protect this ancient creature than most people would ever initially guess. Here's a fact that sounds made up, but is completely real and well documented. The meat of a Greenland shark is poisonous. Not just unpleasant tasting, actually toxic if eaten raw or improperly prepared beforehand. This happens because Greenland sharks lack a normal system for removing waste through urine the way most other animals do. Instead, their bodies build up extremely high levels of a chemical compound that is normally toxic in large concentrations. If a person, or most other predators, eats the raw flesh of a Greenland shark without treating it first, they can experience serious symptoms. These can include severe disorientation, slurred speech, difficulty with basic coordination and balance, and a state that has been described by people who experienced it as feeling extremely and dangerously intoxicated, similar to being extremely drunk, except entirely against their will and without ever choosing to drink any alcohol at all. In Iceland, this shark meat is actually eaten on purpose as a traditional local dish, but only after a long, careful preparation process involving fermenting and drying the meat for weeks at a time to break down and remove most of that dangerous toxin beforehand. Even then, it is still famous today for having an incredibly strong, harsh smell and taste that most first-time visitors from other countries cannot tolerate or handle well at all. Here's the interesting evolutionary angle to consider about all of this. Scientists believe this natural toxicity might actually work as a built-in defense system for the Greenland shark, whether or not that was ever the original biological purpose behind it. In an ocean environment full of other predators that might otherwise view an old, slow-moving shark as a potentially easy target worth attacking, having toxic flesh could reasonably discourage many other predators from trying to eat it in the first place. It is almost like carrying invisible armor, hidden silently inside its own body the entire time, ready without the shark ever needing to consciously use or activate it in any way. This means the very same, slow-moving, seemingly defenseless creature drifting quietly through the freezing darkness might actually be far better protected than it initially appears to any potential predator sizing it up nearby. It cannot outswim a faster predator chasing it down. It cannot fight back aggressively in a direct physical confrontation, but it might not need to rely on either option at all if most other predators nearby already instinctively know, on some deep evolutionary level, that eating this particular shark could make them seriously and dangerously ill afterward. This combination of traits, a body built for extreme patience, a poison-based natural defense system, and senses that do not rely on eyesight at all, paints a picture of an animal that seems perfectly evolved for exactly one specific purpose above all else: quiet, patient, long-term survival across centuries. But humans were not always working from confirmed scientific data about these strange sharks. Long before modern researchers understood any of this, entire communities living near the Arctic had already noticed something deeply unusual about this creature, and they built their own stories and beliefs to try to explain it. Long before scientists ever picked up a research tool, Arctic communities already knew something was strange about this shark. Inuit people have lived alongside the Greenland shark for generations, hunting in these freezing waters long before modern marine biology existed as a field of study at all. And through that long history, stories about this shark grew and spread across generations. Some of these stories treated the shark as a mysterious, almost supernatural creature, one connected to the underworld or to ancient spirits living beneath the ice. Other tales focused on its strange effect on anyone who ate its meat without preparing it properly first, describing people acting drunk, dizzy, and disoriented after a meal, decades before science understood exactly why that happened at all. Keep in mind, these communities had no lab equipment, no eye lens testing, no carbon dating. They only had direct, repeated observation passed down carefully from one generation to the next through stories and first-hand experience. And yet somehow, their instincts were pointing at real, true things the whole time. They recognized the meat could make you sick if handled wrong. They recognized this animal did not behave like other fish they regularly caught nearby. They sensed there was something different, something old and strange, about this particular creature compared to everything else living in those waters. Modern science eventually caught up centuries later and confirmed many of these old instincts with hard data and precise lab testing. The toxic meat, the strange, slow behavior, the deep, mysterious presence in freezing dark water most other animals could not survive in at all. All of it lines up with what these communities had already sensed and passed down through their own oral history and traditions long before modern research ever began. This is not entirely unusual in the world of science as a whole. Many old legends and traditional stories, once written off as pure myth or exaggeration, turn out to contain real, buried truth once modern tools and technology finally catch up centuries later. The Greenland shark is simply one more example added to that same long list. This raises a genuinely interesting point about the shark's reputation among people who lived closest to it for the longest stretch of time. If Arctic communities respected and feared this creature for centuries without any modern scientific proof at all, what exactly did they call it? And why does that traditional name still feel so fitting today, even now that we finally understand the real, confirmed science behind this ancient animal? The answer connects directly to a nickname that has stuck with this shark for a very long time, one that captures its entire personality in just a single word. The Greenland shark has another name, one used often by scientists and fishermen alike: sleeper shark. At first, that nickname might sound almost too simple or even a little silly for an animal this mysterious and ancient. But the more you actually learn about this creature, the more that name fits it perfectly in almost every possible way. The name comes directly from how this shark moves through the water. It does not swim fast. It does not dart around suddenly or chase things aggressively. It drifts. It glides slowly and deliberately through the freezing dark water, almost like it is moving in slow motion compared to nearly every other shark species in the ocean. Researchers who have observed it directly in its natural deep-sea environment often describe its movement as sluggish or even eerily calm and unbothered, especially when compared to faster, more aggressive shark species like the mako shark or the great white shark that most people are already familiar with from documentaries and movies. Some estimates suggest the Greenland shark's typical average swimming speed is slower than a human walking pace on land. Think about that comparison for a second. An enormous apex predator, sometimes growing longer than a minivan, moving through the ocean slower than you casually walk to school in the morning. And yet, this same slow-moving shark somehow survives and even thrives for centuries at a time in one of the harshest, most unforgiving environments found anywhere on our entire planet. The sleeper nickname fits on more than one single level too. It is not just about how slowly this shark physically moves through the water. It also fits the shark's entire overall lifestyle in a much deeper sense. It grows slowly. It matures slowly. It reproduces slowly. Every single part of its biology moves at this same unhurried, patient pace, almost like the entire animal is permanently living in slow motion compared to the rest of the natural world around it. In a strange, poetic way, the name captures something almost philosophical about this creature's approach to survival as a species. While other animals are constantly rushing, chasing, competing, and fighting fiercely just to survive day to day, the Greenland shark seems to be doing the exact opposite the entire time, conserving, waiting patiently, moving at its own unhurried pace, seemingly unbothered by the urgency that defines most of the rest of the animal kingdom. This raises a natural next question worth exploring further. If this shark truly moves this slowly through life in every conceivable way, how does it actually find enough food to survive down there in the freezing darkness in the first place? What exactly is a sleeper shark eating to sustain a life that can stretch on for centuries at a time? The answer might surprise you, because it involves feeding on some of the largest creatures in the entire ocean. You might picture a slow, ancient shark surviving on tiny, easy-to-catch prey, small fish, weak, defenseless creatures unable to escape a predator this sluggish. But the truth about what Greenland sharks eat is actually far more surprising and far more impressive than that simple assumption. When scientists have studied the stomach contents of Greenland sharks caught or found over the years, they have discovered something genuinely shocking: remains of seals, remains of large fish, and in some especially striking cases, remains of other sharks. Even more surprising, researchers have occasionally found remains of polar bears and reindeer inside a Greenland shark's stomach as well, animals most people would never expect to find inside the belly of a slow-moving, sluggish, deep-sea fish like this one. How does an animal that moves slower than a person walking manage to catch and eat creatures like fast, agile seals? For years, this genuinely puzzled scientists trying to piece together its diet, and it still is not 100% fully settled or confirmed even today. One likely explanation is scavenging. The ocean floor in cold Arctic regions occasionally receives something scientists call a whale fall, which is simply the moment a large dead whale sinks all the way down to the ocean floor after dying somewhere above. When that happens, it creates an enormous, long-lasting feast for scavengers living in that area, one that can realistically last for months or even years before it is completely consumed. A Greenland shark does not need to be fast to take full advantage of a meal like that. It just needs to be patient, and patience is something this particular shark clearly has in nearly unlimited supply. This alone could explain a significant portion of its diet, especially the larger prey items like seals or other bigger animals that scientists sometimes find partially inside its stomach. But scavenging alone might not fully explain everything researchers have found so far. The presence of polar bear and reindeer remains is especially strange and puzzling, since neither of those animals would naturally end up on the ocean floor through scavenging alone under normal circumstances. This raises a genuinely fascinating possibility that some scientists have started to seriously consider and investigate. What if this shark, despite moving so incredibly slowly nearly all the time, is not purely a scavenger after all? What if, at least occasionally, it is also a stealthy, patient, and surprisingly effective active hunter in its own right? That single possibility would completely change how scientists think about this animal, and it connects directly to a much bigger and more interesting mystery. How exactly does something this slow manage to successfully catch live, fast-moving prey in the first place, out there in the pitch darkness of the deep Arctic Ocean? Let's dig deeper into one of the biggest clues scientists have found about how this shark survives for centuries: the whale fall. When a large whale dies out in the open ocean, its massive body eventually sinks all the way down to the ocean floor below. This single event creates one of the largest and longest-lasting food sources found anywhere in the entire deep sea environment. A whale carcass can weigh many tons, and it can take scavengers months, sometimes even years, to fully consume everything down to the bone. For an animal built entirely around patience and extreme energy conservation, a whale fall is essentially the ultimate jackpot. Researchers have directly documented Greenland sharks gathering around whale falls in multiple different locations, feeding steadily on the remains for extended periods of time. This fits perfectly with everything else we already know about this shark's slow, careful, energy-conserving lifestyle in general. Why would an animal built for extreme patience and energy efficiency waste enormous amounts of precious energy constantly chasing down fast-moving prey when it could simply wait, quite literally, for years if necessary, for a massive meal like this one to essentially fall directly into its path? This single feeding strategy alone could easily sustain a Greenland shark for extremely long stretches of time between individual meals. Scientists studying deep-sea ecosystems in general already know that many species living down in the abyss have evolved to survive on very little food overall, sometimes going remarkably long periods between substantial meals of any kind. The Greenland shark appears to take this same basic survival strategy to its most extreme possible level, perfectly matching its unusually slow metabolism and its incredibly long overall lifespan. Think about the sheer efficiency of this particular strategy for a moment. Instead of burning through valuable energy every single day, constantly searching for smaller, more frequent meals scattered throughout its territory, the Greenland shark can patiently wait for one enormous meal to sustain it for months or possibly even years at a time before needing to feed substantially again. In a strange and almost poetic way, this feeding strategy mirrors the shark's entire approach to life as a whole in nearly every other regard. Patient, efficient, playing a long, extended game across a very long timeline, rather than rushing toward any kind of immediate short-term reward or gratification. But scavenging alone does not fully explain everything scientists have discovered so far about this animal's diet and feeding behavior overall. Remember those seal remains and the other faster, more agile prey items found inside its stomach during past research. This leads directly into an even stranger and more surprising possibility that some researchers have begun to seriously consider. What if this ancient, slow-moving shark is not purely relying on scavenging alone to survive after all? Here's where the Greenland shark story gets even stranger and harder to fully explain. Scientists have found remains of seals inside the stomachs of Greenland sharks, and seals are fast, agile swimmers, more than capable of quickly outswimming a shark that moves slower than an average person walking on land. So, how exactly does this happen? There are a few genuinely compelling theories currently being explored and debated by researchers studying this exact question. One strong possibility involves catching seals while they are sleeping. Seals sometimes rest or sleep directly in the water rather than on land or solid ice, and during that vulnerable resting period, they are far less alert and aware of potential danger nearby. If a Greenland shark could slowly and carefully approach a resting, unaware seal without being detected in time, it would not need to be fast at all to succeed in catching it. It would only need to be patient, quiet, and nearly undetectable while closing the remaining distance. Another compelling theory focuses on ambush hunting as a core strategy. Remember, this shark's entire body has evolved for extreme stealth, patience, and staying almost completely still and undetected for very long stretches of time. If it can position itself directly beneath unsuspecting prey without being noticed at all, it may only need one single, sudden burst of movement to strike successfully and catch a meal, rather than needing sustained speed over any real distance to chase something down. Some researchers have also pointed out that Greenland sharks may actually be capable of brief, short bursts of speed for small distances. Even though their normal everyday cruising speed the rest of the time remains extremely slow. This would work similarly to how a person who normally walks everywhere calmly might still be capable of a short, sudden sprint if a moment of real urgency or necessity ever demanded it unexpectedly. The shark would not need to maintain that higher burst speed for very long at all. It would only need it for one single, precise, well-timed moment of attack against unsuspecting prey nearby. This combination of patience, stealth, and a rare short burst of surprising speed could potentially explain how a fish this slow manages to occasionally catch live, agile prey like a seal, despite its otherwise extremely sluggish everyday lifestyle and behavior. It paints an entirely different picture of this ancient shark, one that goes far beyond a simple, passive scavenger, patiently waiting around for food to arrive on its own. It suggests a surprisingly capable, patient, and quietly effective predator, one perfectly adapted through millions of years of evolution to thrive within its own unique and extreme rules of survival. This raises one more fascinating and still unresolved question that scientists continue to investigate today. If this shark truly can hunt live prey successfully under the right circumstances, how exactly does it manage to move so little overall, conserve so much precious energy, and still consistently succeed at finding enough food across centuries of life? The answer connects directly to a much deeper and more interesting overall mystery about this animal's biology and survival strategy as a whole. Here is a genuine puzzle that continues to fascinate scientists studying this animal today. The Greenland shark barely moves compared to almost every other large predator found anywhere in the ocean, and yet it somehow survives and even thrives for centuries at a time in one of the harshest, most demanding environments found anywhere on this planet. How does something that conserves this much energy consistently find enough food to sustain a life that stretches on for 400 years or more? Part of the answer connects directly back to its incredibly slow metabolism, something we already explored earlier in this story. If an animal burns energy at only a small fraction of the rate most other similarly sized animals do, it naturally requires far less food overall just to survive and stay alive from day to day. Think of it like a car that gets an extraordinary number of miles per gallon of fuel. It can travel an enormous distance on a relatively small amount of fuel compared to a less efficient vehicle covering that exact same distance. The Greenland shark's entire body appears to function in a remarkably similar way. It runs on an extremely small amount of biological fuel relative to its overall size, and that single trait alone could explain a massive part of how it survives so successfully on so little food or activity overall. Scientists have also discovered that Greenland sharks tend to spend significant amounts of time at very specific, consistent depths in the ocean, rather than constantly roaming and searching across vast distances, the way many other large ocean predators typically behave. This suggests the shark may be relying heavily on ambush-style tactics combined with scavenging opportunities, rather than active, constant, wide-ranging pursuit of prey across large areas like a great white or mako shark might regularly do. Staying mostly still and waiting patiently costs dramatically less energy overall than constant, sustained searching and swimming ever would. This entire approach fits perfectly with everything else we already know about this animal from earlier in the story. Slow metabolism, slow heart rate, slow overall growth. A body seemingly built from the ground up for extreme, long-term efficiency rather than speed, agility, or aggressive pursuit of prey. Every single piece of this evolutionary puzzle fits neatly together into one unified picture. This is an animal that has essentially mastered the art of doing remarkably little, and somehow doing it exceptionally well enough to survive for centuries as a direct result. But this pattern of extreme conservation and patience raises an entirely new and different kind of mystery, one that goes beyond simply eating and surviving day to day. If this shark conserves this much energy in absolutely everything it does, what does that same pattern mean for how and when it actually reproduces across its incredibly long lifetime? The answer to that particular question turns out to be even stranger and far more mysterious than anything we have already covered so far. Get ready for one of the strangest facts in this entire story. Female Greenland sharks might not reach full sexual maturity until they are approximately 150 years old. Read that again, slowly, and really let it sink in for a moment. 150 years old, and that is simply the estimated age when a female shark becomes capable of reproducing for the very first time in her entire life, not anywhere close to the end of her natural lifespan overall. To put that number into a perspective your brain can actually process, imagine if a human being could not have children until they had already lived for well over a full century themselves. It sounds almost absurd and completely impossible from a normal human perspective. Yet for the Greenland shark, this is simply normal biology, the standard timeline for its particular species compared to every other shark in the ocean. Scientists arrived at this estimate using the same basic growth rate calculations we already covered earlier in the story. If a Greenland shark grows at roughly 1 centimeter per year, and researchers have observed the approximate size at which females typically first begin reproducing successfully, they can calculate roughly how many years it likely takes to reach that specific size and stage of development. That math points toward a truly staggering number over a full century of life before a single female shark ever produces even one offspring for the very first time. This raises an obvious and fairly serious question about the entire species as a whole. If female Greenland sharks take this incredibly long just to reach reproductive maturity, how does this species manage to successfully survive and continue on at all as a population over time? Every single individual shark represents an absolutely massive, multi-generational investment of time before it can even begin contributing new sharks to the overall population. This single fact also helps explain why Greenland sharks are considered especially vulnerable and at risk today in the modern world. If a fishing net or a discarded piece of fishing gear accidentally kills a young shark before it ever reaches 150 years of age, that individual shark never gets the chance to reproduce even a single time in its entire natural life. Multiply that same tragic pattern across many sharks lost over just a handful of decades, and you can already start to see a genuinely serious long-term problem quietly building for this species as a whole. This slow reproductive timeline also connects directly back to the shark's overall survival strategy in general. Slow growth, slow metabolism, slow reproduction, every single piece of its biology moves at this same extremely unhurried, patient pace, almost as if the entire species itself operates on a timeline that barely resembles any other creature we know of on this planet. This raises another fascinating and still unresolved question that scientists continue to investigate closely today. If female Greenland sharks take this incredibly long just to reach reproductive maturity in the first place, what do scientists actually know so far about how these ancient sharks reproduce successfully once they finally do reach that long-awaited point? Here's something that might genuinely surprise you. Despite everything scientists have already learned about the Greenland shark's extreme age and remarkably slow biology, they still know remarkably little about exactly how this species actually reproduces in the wild. This is not because researchers have not tried repeatedly to study this exact question in detail. It is because Greenland sharks live so far down in the deep, freezing ocean, and their entire reproductive process happens so rarely and so slowly overall, that actually observing it directly in the wild has proven to be extraordinarily difficult, even with modern research technology and equipment available today. Scientists do know that Greenland sharks are what researchers call ovoviviparous. That means the babies, called pups, actually develop inside eggs, but those eggs stay and hatch inside the mother's body, rather than being laid externally like many other fish species. The mother eventually gives birth to fully formed, live baby sharks, rather than laying external eggs the way many people typically picture when they imagine fish reproduction in general. Researchers have recorded one Greenland shark carrying an estimated 10 pups inside her body at one time, based on a limited number of documented cases studied so far. But beyond that single basic fact, an enormous amount about this specific process still remains genuinely unknown or unconfirmed by science today. How long does pregnancy actually last for a Greenland shark? Where exactly do mothers go to give birth successfully in such an extreme environment? How often does a single female actually reproduce successfully across her entire multi-century lifespan? These are not simple, easy questions for scientists to answer using normal research methods, mainly because studying an animal that lives this deep, moves this slowly, and reproduces this infrequently over such an enormous timescale is incredibly difficult using the research tools and technology currently available to marine biologists today. You cannot simply follow one individual shark around for decades or centuries, waiting patiently to directly observe its natural reproductive cycle in real time. Human researchers and scientific careers simply do not last nearly long enough to make that kind of extended, continuous observation realistically possible using current methods and technology. This means huge portions of the Greenland shark's basic reproductive biology remain a genuine, unsolved mystery even today. Despite everything else, scientists have already managed to learn and confirm about this remarkable animal through other creative research methods over the years. It is a humbling reminder that even with all of our modern science, technology, and advanced research tools, some secrets about the natural world remain stubbornly out of reach, at least for now, hidden deep beneath the ice in freezing, pitch-black water most humans will never personally see or explore firsthand. This leads directly into one of the biggest unanswered mysteries connected to this entire topic, one that remains completely unsolved by science even today. Where exactly do these ancient sharks actually go to give birth? Here's a mystery that might genuinely surprise you. Despite decades of dedicated scientific research and study, nobody has ever found a Greenland shark nursery. Not one single location, anywhere in the entire ocean, has ever been confirmed by scientists as a place where these sharks reliably go to give birth to their young. For comparison, many other well-studied shark species have known and confirmed nursery areas. Specific, predictable locations where pregnant females reliably travel to give birth, and where young, vulnerable pups can grow safely for a while before venturing out into more open and dangerous water on their own. Scientists have successfully identified and documented these exact kinds of nursery locations for species like great white sharks and several other shark species found around the world. But for the Greenland shark specifically, this critical piece of the puzzle remains a complete and total mystery, despite years of dedicated searching and research. No young Greenland sharks, or very few at most, have ever actually been found or documented by researchers in the wild. Think about that for a moment. An animal that can grow longer than a school bus, and that is believed to live for several centuries, and yet scientists have almost never directly observed or documented what a young, newborn version of this same shark actually looks like in its natural habitat. Where are all the baby Greenland sharks? Where do mothers travel to give birth safely? And where do young, vulnerable pups spend those critical, dangerous, early years of their extremely long lives before growing large enough to be regularly seen and documented by researchers? This remains one of the single biggest unanswered questions connected to this entire species today. Some scientists suspect the nursery grounds might be located extremely deep, likely far deeper than most current research equipment, and methods can easily and reliably reach on a consistent basis. Others believe young sharks might simply be extremely good at avoiding humans and research equipment entirely during those especially early and vulnerable years of life, staying hidden in areas researchers rarely explore in the first place. It is also entirely possible that young Greenland sharks look different enough from fully grown adults that researchers may have already accidentally seen them before without realizing what they were actually looking at during their research. Whatever the true, complete answer eventually turns out to be, this remains a genuine, significant gap in our overall scientific understanding of this species. An animal old enough to have witnessed major turning points throughout human history, and yet we still have not fully solved the basic mystery of where its own species is actually born in the first place. This kind of significant unsolved mystery does raise a genuinely exciting question about the future of this species and its ongoing scientific study. If scientists can eventually solve mysteries this deep and this complex about a shark this old, what other secrets might this ancient, slow-moving creature still be hiding from us? Some researchers believe the answer could eventually connect directly to something enormous for humanity as a whole, extending in scope far beyond sharks alone. Here's a genuinely exciting question that has captured the serious attention of scientists working far outside the world of marine biology alone. If a Greenland shark can somehow live for 400 years, or possibly even longer, without its body completely breaking down from age, what if studying that exact biological process could eventually help humans live longer, healthier lives too? This is not simple science fiction or empty speculation without any real basis. Researchers studying human aging and longevity have already started paying very close attention to animals like the Greenland shark specifically for this exact reason. The basic logic driving this research is fairly straightforward to understand. If scientists can identify and fully understand exactly what allows this shark's cells to resist the kind of damage and breakdown that eventually causes aging in most other animals, that same fundamental knowledge might eventually be applied, in some meaningful form, to human biology and medicine as well. This growing field of scientific study is often called comparative biology or comparative gerontology, and it involves carefully studying animals with unusually long lifespans, specifically to better understand the actual aging process itself on a deeper level. The Greenland shark is quickly becoming one of the single most interesting and promising case studies in this entire growing field of research. Because remember, this is not simply an animal that happens to live for a very long time by pure chance or lucky circumstance. This is an animal that appears to somehow avoid, or at the very least significantly slow down, many of the normal biological breakdown processes that eventually cause aging, disease, and death in almost every other living creature we know of on this planet. If scientists can eventually figure out exactly how the Greenland shark cells manage to avoid this kind of damage and gradual breakdown over such an enormous timescale, that discovery alone could potentially open up entirely new avenues of medical research focused specifically on human aging and disease prevention in the future. This does not mean scientists are anywhere close to literally extending human lifespans out to 400 years using shark biology anytime soon. That kind of direct, dramatic outcome remains firmly in the far distant realm of science fiction for now, at least based on where the actual research currently stands today. But even small, incremental insights and discoveries taken directly from this shark's unique biology could potentially help scientists better understand and possibly even help slow down certain specific aspects of human aging and disease over time. This is precisely why so many current researchers remain deeply fascinated and genuinely excited by this particular species overall. It represents far more than simply an interesting biological curiosity or a strange record holder for lifespan alone. It might actually be a genuine potential key to understanding one of the biggest and most persistent unsolved mysteries in all of human biology and modern medicine combined. This raises an obvious and important next question. What exactly are scientists currently looking for at the genetic level inside this animal? And what specific genes might actually be directly responsible for its remarkable, almost unbelievable longevity? Every single living thing on this planet carries genes, which are essentially detailed biological instructions that tell the body precisely how to grow, function, and repair itself over time when needed. Scientists studying the Greenland shark are specifically racing to understand which exact genes might be directly responsible for its almost unbelievable lifespan, compared to nearly every other animal we know of on Earth. This particular area of research is still relatively new and ongoing, but early findings and results so far have already been genuinely fascinating to researchers in the field. Scientists have specifically been looking closely at genes related to DNA repair. Every single day, the DNA inside your own cells experiences small amounts of natural damage, similar to how a well-used book might slowly pick up small tears, creases, or smudges after being read and handled repeatedly over a long period of time. Most living things have biological systems in place, specifically designed to repair this kind of everyday damage. But those repair systems are not perfect or flawless by any means. Over time, in most animals, unrepaired damage steadily builds up, and many scientists believe this gradual accumulation of damage is a significant part of what actually causes aging at the cellular level. Some early research specifically suggests the Greenland shark might have unusually effective and efficient DNA repair systems compared to most other animals studied so far. If true, this would mean its cells are simply better at fixing everyday damage before that damage has any real chance to meaningfully build up and cause long-term problems over time. Scientists are also very closely studying genes related to cancer resistance in this species. Cancer happens when damaged cells begin growing and dividing uncontrollably instead of functioning normally. Given how astonishingly long a Greenland shark lives, and how much time that gives potentially harmful cell mutations to occur and accumulate naturally, you might logically expect this species to experience extremely high rates of cancer throughout its long lifetime. But that does not appear to be the case at all. Based on current research and observation, this has led many researchers to strongly suspect the Greenland shark might have specific genetic defenses that actively work to help prevent, catch, or repair harmful cell mutations well before they ever have a real chance to develop into serious, dangerous cancer. If scientists can successfully identify the exact genes directly responsible for this kind of natural cancer resistance, that specific discovery alone could potentially prove incredibly valuable and important for human cancer research as well moving forward. This particular field of scientific research remains very much active and ongoing today, with new discoveries and findings still being made on a fairly regular basis. But every single new discovery adds one more important, valuable piece to this larger overall puzzle, slowly helping scientists understand exactly what makes this remarkable, ancient shark so biologically different and unique compared to almost every other animal alive on our planet today. This naturally raises an interesting related question. How does the Greenland shark actually compare to other famously long-lived animals also being closely studied by scientists for these same exact reasons? The Greenland shark is not the only animal on Earth famous for living an unusually long time, though it does currently hold the record among all animals with a backbone. Comparing it to other long-lived species helps put its own achievement into a much clearer and more meaningful perspective overall. Take the bowhead whale, for example, an animal we already briefly mentioned earlier in this story. Bowhead whales can live well past 200 years old, and scientists studying them have found evidence suggesting unusually effective and efficient DNA repair systems at work, very similar in basic concept to what researchers now suspect about the Greenland shark as well. Two very different animals, a massive whale and a slow-moving shark, may have independently evolved somewhat similar biological solutions to the exact same fundamental problem of aging and cellular damage over time. Then there is the humble tortoise, another well-known and often mentioned example of extreme longevity in the animal kingdom. Some giant tortoise species can live well past 150 years old, and one famous individual tortoise reportedly lived to be roughly 190 years old before eventually passing away of natural causes. Tortoises also share several key traits in common with the Greenland shark, including a notably slow metabolism and a generally slow, unhurried, low-energy overall lifestyle day to day. Beyond vertebrates entirely, certain species of clam have been documented, living for several centuries as well, and scientists studying them have identified some genuinely fascinating patterns connected to slow metabolism and reduced cellular stress over time, very similar conceptually to patterns already discussed earlier regarding the Greenland shark. What almost all of these extremely long-lived species tend to share in common is a slower metabolism, a generally cold or notably stable environment, and unusually efficient internal systems for repairing everyday cellular damage before it can meaningfully build up over time. This strongly suggests a real, meaningful, and possibly universal biological pattern, connecting slow living directly to long living across many completely different branches of the entire animal kingdom, not just one single species studied in isolation. But even within this small, exclusive group of remarkably long-lived creatures, the Greenland shark still stands out as something truly exceptional and unique overall. It is not simply on the general list of unusually long-lived animals. It currently sits firmly at the very top of that list among every single animal with a backbone ever formally studied and confirmed by science to date. This comparison across completely different species strongly reinforces a much bigger, unifying idea running throughout this entire story so far. Slow living and long living appear to be deeply and fundamentally connected at a biological level, and the Greenland shark simply represents the single most extreme, most exceptional version of that same repeating pattern found anywhere in the natural world. This raises one final important, practical question. Though, if scientists genuinely want to keep studying this incredible animal moving forward, how exactly do they even track and follow a creature that lives this deep, moves this slowly, and survives for so many centuries at a time? Studying an animal that lives this deep and moves this slowly presents a genuinely serious practical challenge for scientists. You cannot simply follow a Greenland shark around visually for years at a time, and you certainly cannot follow one for centuries to observe its complete natural life cycle from beginning to end. So instead, researchers have turned to a clever and increasingly popular method called satellite tagging to help solve this exact problem. Scientists carefully attach a small electronic tracking device directly to a shark's fin or body. This specialized device is specifically designed to record important data like the shark's overall location, its typical swimming depth, and the surrounding water temperature at regular intervals over an extended period of time. Some of these advanced tags are built to eventually detach on their own after a set period of time, floating up to the ocean surface where they can transmit all of their collected data directly to satellites orbiting high above the Earth. This method has already revealed some genuinely fascinating and previously unknown information about how Greenland sharks actually move and behave out in the wild. Researchers have discovered that these sharks are capable of traveling much farther overall than most scientists originally assumed or expected. One particular tagged shark was recorded traveling several thousand miles from where it was originally tagged near the coast, roughly comparable to the distance between New York City and Los Angeles. This came as a genuine surprise to researchers, given how slowly this same species generally moves through the water on a daily basis. It turns out that while a Greenland shark's everyday swimming speed remains extremely slow overall, that same slow and steady pace, when sustained consistently over long, uninterrupted periods of time, can still add up to some genuinely impressive total distances covered. Tagging studies have also revealed that Greenland sharks tend to dive to significantly greater depths during the daytime hours and then rise back up closer to the surface during nighttime hours instead. Scientists believe this regular daily pattern likely connects directly to the natural daily movements of their prey, which may also shift and change position vertically within the water column throughout each day and night cycle. This growing body of tracking data is helping researchers finally piece together a much more complete and accurate picture of how these mysterious sharks actually live and move through their environment, filling in several important gaps left behind by decades of earlier research that relied mainly on very limited direct observation alone. Every single new tag deployed and every fresh new set of data successfully recovered adds another valuable piece to this still growing puzzle. But all of this exciting new information and progress also comes with a genuinely serious warning attached, because for an animal that takes centuries just to grow, mature, and successfully reproduce even once, any modern threat to its long-term survival becomes an especially serious and urgent problem to fully understand and address quickly. Here is a sobering thought to sit with for a moment. An animal that can survive some of the harshest, most extreme conditions found anywhere on this entire planet, freezing cold water, crushing deep ocean pressure, and almost complete darkness for its entire life, might still be seriously threatened by something else entirely. Modern human activity. Greenland sharks face several serious, ongoing threats directly connected to human activity today. Accidental capture in commercial fishing equipment, often called bycatch, remains one of the single biggest and most immediate threats to their overall survival as a species. Because Greenland sharks tend to live and swim in some of the exact same general areas where commercial fishing boats regularly operate, they frequently end up accidentally caught in large fishing nets or on long fishing lines, meant originally for completely different target species entirely. For most fish species, losing a certain percentage of the overall population to this kind of accidental bycatch might not be a serious existential problem in the bigger picture. Many other fish species reproduce quickly and in extremely large numbers, allowing their overall population to naturally recover relatively fast after a temporary decline of any kind. But remember, female Greenland sharks might not even reach reproductive maturity until they are roughly 150 years old. This single biological fact changes everything about how scientists think about this specific threat. If a young Greenland shark is accidentally killed before it ever reaches that critical age of reproductive maturity, that individual shark never gets the chance to contribute a single new shark to the overall population, not even once in its entire natural life. Multiply that same tragic pattern across many sharks lost prematurely over the span of just a few decades, and you begin to see a serious, compounding, long-term problem quietly building for the entire species as a whole. Climate change presents another significant and growing threat as well. Greenland sharks depend heavily on very specific, extremely cold water temperatures to survive successfully in their current habitat and range. As ocean temperatures continue gradually rising worldwide due to broader climate change, the specific habitat this species depends on could shrink or shift substantially over time, potentially forcing sharks into unfamiliar new territory or dramatically altering the delicate balance of their existing ecosystem in ways scientists do not yet fully understand or predict. Pollution represents yet another serious and ongoing concern for this species as well. Because Greenland sharks live for so many centuries, they have significantly more time than almost any other animal to gradually accumulate toxins and pollutants directly within their own body tissue over their extremely long lifetime. Scientists have already detected concerning levels of certain pollutants in Greenland shark tissue samples collected and studied in past research. This raises a serious and urgent question that extends far beyond simply protecting one single remarkable species alone. What exactly do we stand to lose as an entire planet if this ancient, unique creature and everything it represents were to eventually disappear completely from our oceans forever? Think about this from a genuinely different angle for a moment. When a Greenland shark dies today, whether from natural causes or from direct human impact, what exactly is actually lost in that single moment? It is not simply the loss of one single fish among many others in the ocean. It could easily be the loss of a living creature that was already alive and swimming through these same waters since before the United States existed as a country at all. It could be the loss of a direct, living link connecting our current modern world all the way back to a time period most of us can only ever read about carefully in history books or documentaries. Every single Greenland shark alive today potentially represents centuries of accumulated survival, adaptation, and successful biological success, all contained within one single living creature, swimming quietly through the freezing dark water right now. When that individual animal dies, all of that irreplaceable accumulated history disappears permanently and completely along with it, especially when you remember it might take another full century or more before a young shark alive today ever reaches full reproductive maturity to help replace it in the overall population. This is fundamentally different from losing an animal that reproduces quickly and abundantly, and whose overall population can realistically bounce back within just a handful of years following a decline. For the Greenland shark specifically, population recovery, if it can happen successfully at all following any serious decline, would likely take multiple centuries to fully play out and stabilize again. That is an almost incomprehensible timeline for humans to properly plan carefully around or even fully wrap our heads around in the first place, especially considering how differently we tend to experience and measure time ourselves. This raises a genuinely bigger and more important question that extends well beyond just one single species alone. What does it actually mean for humanity as a whole to share this exact same planet with a creature that experiences and measures time so completely differently than we do? This shark has personally witnessed centuries of human history unfold from a distance. It was already alive during major wars, significant discoveries, and dramatic historical turning points that most of us today only ever get to read about carefully in books or watch in documentaries. And it continues on, right now, in this exact moment, almost entirely unaware and unaffected by any of it happening above the surface. There is something genuinely humbling, and even a little unsettling, about sharing our exact same planet with a creature like this one. An animal that makes our own individual human lives look incredibly brief and fleeting by direct comparison, and yet remains almost completely unknown and mysterious to most people, despite having lived among us, quietly and patiently, the entire time. This brings us to one final, important question to properly close out this entire story. What can this ancient, mysterious shark actually teach us about our own limited understanding of time itself, and about our own fleeting place within it? We started this journey with a single, mind-bending idea: a shark, alive today, swimming right now in freezing dark water, was already alive before the United States existed as a nation at all. After everything we have explored together throughout this entire story, that same original idea should feel even more powerful and meaningful than it did at the very beginning. The Greenland shark forces us to seriously reconsider what we actually think we know and understand about time, about aging, and about what is genuinely possible within the boundaries of biology itself. It shows us that slow, patient, and quiet can still mean powerful and enduring in its own unique way. It shows us that speed and urgency are not the only successful strategies for survival found in nature. Sometimes, patience and quiet endurance can prove to be the most powerful survival strategy of all, stretched out across a timeline that barely makes sense to a species like ours that tends to rush constantly through our own comparatively brief lives. This ancient shark also reminds us, in a deeply humbling way, just how much we still genuinely do not know about the natural world around us. Even today, even with all of our advanced modern science and technology readily available, we do not know exactly where these sharks are born. We do not fully understand every single detail of how they successfully reproduce across such an enormous timescale. We are still actively working to fully uncover every secret hidden within their unique and remarkable biology. And yet, Despite everything we still do not know for certain, we already know enough to understand this creature is truly one of the most remarkable, extraordinary animals alive on our entire planet today. A living, breathing connection stretching all the way back through centuries of human history, quietly drifting through freezing dark water the entire time, almost completely unaware and unaffected by everything happening above the surface. Somewhere out there, right now, in this exact moment, a Greenland shark is still swimming. It might already be older than any human structure currently standing anywhere on Earth today. It might already be older than most of the historical documents most of us were ever taught carefully about in school, and it will likely keep swimming on quietly, long after all of us are gone from this world completely, continuing its own slow, patient journey through time in a way that makes our own human lives look incredibly brief by comparison. The next time you think about how fast your own life feels like it is moving, or how quickly time seems to pass you by day to day, remember this ancient, mysterious creature drifting patiently through the freezing, dark Arctic depths. Remember that somewhere out there, right now, time is moving so much slower for one particular animal, and that same animal has already outlived nearly everything and everyone we have known throughout our own dramatically shorter human lives. The Greenland shark does not just survive time. In its own quiet, patient way, it seems to have found a way to truly master it,